Okay, so this is 7-1. So the entire category or theme, the entire theme of chapter 7, you with me, is puzzle. It's a giant puzzle. You have your formula sheet in front of you. You have your formula sheet right here. You can see this is your unit circle, and then you're going to see stuff we have already discussed. Some of it you already know. Some of it you already know, but I just put it on here so your brain doesn't have to think that much about it. You got sine, cosine, tangent. You've got the reciprocal function. If you notice these are the reciprocal functions. Here, this is the whole even and odd stuff that we talked about. Here is the another way to write tangent in terms of sine and cosine, and then of course its reciprocal function. So those we've already practiced with. Down here is all the new stuff. And you can see clearly why I'm not making you memorize it. There is a lot, okay? Now, there is one that I would strongly suggest memorizing because it makes life easier with what we're fixing to do, and that's this one. I would really suggest memorizing this. Sine squared plus cosine squared equals 1. I would memorize that. It makes life easier, okay? Then I would also remember, which we're fixing to go over, how to get these two. Not memorize them, but just remember how to get them, okay? The mid chapter 7 will be on paper, and the end of chapter 7 will also be on paper. If you score poorly on the mid, I will replace, if you score better on the end, I will replace that grade over your mid grade, okay? Because it does build on it, and you've shown improvement. You will notice I have also already given you an extra credit assignment. That extra credit assignment, I'll decide when it's going to be due. I think, did I accidentally type it on there when it's due?
You just said Unit 6 though.
Due Friday, 2:10 when you walk in the door. Specific instructions.
Yeah, ignore that. Usually we're in chapter 7 by the beginning of, or by mid-February. We've had a lot of snow days and closures, so we're fine. Everything's fine. So anyways, that extra credit, I'll give you an actual due date for it right now. Just hold on to it and start working on it. No, you cannot use AI because AI actually cannot do this. It's a puzzle, okay? To give you an overall idea of how we're doing these trig identities, it's a giant puzzle. And so it really is not one exact approach the same every time. Your approach may be different than your neighbor's, but you both may be right. Okay? Which is exactly why we're taking this on test. So let's just dive right in. Oh my. That I give. Yeah, when we go to theme parks or when they go hiking, I clip it to his shorts. Okay, so look right here. These are on your formula sheet. This is old news. This is stuff we've already done before. The only one that you may be a little bit rusty on are these three right here. These are even and odd relationships. If you plug in the negative angle to sine, then you're going to get the same thing as if you had just multiplied a -1 times sine of that angle. If you plug in the negative angle to cosine, you're going to get the same thing as if you had just evaluated cosine of the positive angle, and so forth. Now, the takeaway from all of this, right? All of it. If you recall, coordinate points that are x, y, we said to start thinking of them as what stands for x? X is which trig function? Don't go to cosine, don't go to Costco, remember that? So cosine of theta is x, and what was sine? Y, sine. Remember that? So recall that your typical xy is cosine theta, sine theta. Okay? So what I want to do, instead of just throwing the formulas at you, I want us to derive them. Derive means you're going to see how they came about. So look at this formula right here. X squared plus y squared equals 1. What formula does this resemble? What does this resemble? Thank you. It's the Pythagorean theorem for the unit circle. Recall for the unit circle, if you remember this, right? The radius was 1, and then you had the x coordinate and the y coordinate. Remember that? Okay, so this is the Pythagorean theorem, but with the unit circle. What did we say x stands for? Which trig function? Cosine. So I'm going to replace this with cosine theta. Copy the squared. What does y stand for? Sine. Copy the squared equals 1. Now, what is cosine times cosine? Because that's what this means, right? Cosine times cosine. Yes? It is cosine squared. You are not squaring theta. You're squaring cosine, okay? So don't write, red means wrong here. Don't write cosine theta squared. Don't write that. That's squaring the angle. That's totally wrong. You're going to write, and look, it feels weird to write it this way, but it's accurate. You're going to write cosine squared theta. Okay? And then what would this become? What's sine theta being squared? Thank you. Don't overthink it. It's sine squared theta. Bring down the 1. Now, cosine squared plus sine squared equals 1. Or, I'm just going to shuffle these two. I don't know why, but sine squared plus cosine squared has a better ring. So all I did was shuffle them, right? Do you notice that? This is the very first formula that I need you to familiarize yourself with. And remember over here we said do what? Memorize it. You see how this came about? All we did was replace x with cosine, y with sine, and then we cleaned it up. Now, these are one and the same. These are one and the same. But this is the one you're going to see and use more often. Okay, so now what I want to do is I want to play around with this. I'm going to drag, this is a domino effect. We're going to copy it over here. And now we're going to see what other type of function formula can I come up with. I'm going to divide everything by sine squared. Now remember, whatever you do to one side, you do to the other, right? So I'm just going to say, okay, I'm going to divide this whole thing by sine squared. Divide this whole thing by sine squared. And divide this by sine squared. Now here's why I chose that. Because what's anything divided by itself? 1. So you see how right here, all of a sudden I have a 1. Right? Now, you could leave this as it is, or you could write your trig identities. Come up here. What is cosine over sine? Go to your formulas. It's cotan. Well, if they're both squared, then it would be cotan squared. Okay, what is 1 over sine? Look at your formulas. Cosecant, but this one's squared, so it would be cosecant squared. Do you see how we got that? Now look at your formula sheet. Do you see it right here? So that's how that formula came about. I'm not asking you to memorize it. I'm showing you how these came about. They didn't just pull them out of thin air. Now let's repeat. So this is another one. I'm going to box it in. This is another one that's done. Yep. Cosine squared, right? I'm going to copy that exact same original over here. And this time I'm going to divide by cosine squared. So the rules of manipulating equations are going to apply a lot in this chapter. Whatever you do to one side, you have to do to the other. Now, let's look at it carefully. I could leave this as sine squared over cosine squared, or I could use the identity. Sine over cosine is actually tangent, but they're both squared, which means I'll write tan squared. Now, they do have to both be squared for you to do that, okay? If one was squared and the other was not, you could not write tan squared. They have to match. What would happen is you could pull the one sine over cosine and write tan, and then you would have the other one left over. Now, what does this give me? That's a 1. And then what's 1 over cosine? And it's squared, so it's going to be secant squared. And if you look at your formula sheet, you're going to notice that that's the third equation for a trig identity. It's right here. You see it? So what we've just done is derived these three. Now, we're not going to derive really any more right now. We will later, but let's run with those three first. Okay? Again, puzzle. Now, up here at the top are these three that we just derived. These are the three we just found. Then over here, you're going to notice here's equivalent forms. When I say a cup game, do y'all know that game where you have 3 cups and you put a ball under one and then you're just shuffling them? Okay, this is a cup game. Notice this is sine squared plus cosine squared equals 1. If I subtract cosine squared to the right, I end up with sine squared equals 1 minus cosine squared. You see that? All I did was take this off and subtract it right here behind it. So that's a cup game. They just took something and moved it to the other side, and then they said, bam, here's a new formula. And then they did that multiple times. Here, they took sine squared, moved it to the other side. So cosine squared equals 1 minus sine squared. Here, they took cotan squared and moved it to the other side. And they ended up with 1 equals cosecant squared minus cotan squared. You see how all those came about now? It's just a cup game. Not looking for you to memorize them. And you're going to notice they're not on here. They're not on here at all. Like, none of these are on here. Why? Well, good grief. The formula sheet's already... Imagine if I'd added that to it. So you've got to know that, yes, these three here are helpful, but there's more if you just shuffle things to the other side, okay? So keep that in the back of your mind. They do come up down the road. All right. This is just, do you know how to multiply trig identities? And do you know how to factor? So this is, and you treat them like variables. Okay, so watch. So first of all, let's also always recall tan of x, meaning where x is like the angle, is just sine over cosine, right? Always keep that in the back of your mind. And if you don't like using x, because it makes you think cosine, then write theta. But they're going to use x a lot here, but it does represent the angle, okay?
Who made this up? Who decided that this would be a great thing to teach people?
So fun. I love it. All right. Multiply and simplify. Here we go. We're going to multiply cosine x into this set of parentheses. First of all, please recognize with the plus and the minus signs how many terms there are. How many terms are in here? In here. Just 2, right? So when I multiply this, how many terms will I end up with? 2. So here we go. Now, here's the beautiful thing about it. They just shove together if they don't match. So what's cosine times tan? Cosine tan. Isn't that neat? What's cosine times negative secant? Negative cosine secant. Now, that's the multiplication part. Now you have to clean it up. How do you clean it up? Here's where everyone starts separating in different directions. Your mind may not see it the same way your partner sees it. Now, right here, everyone should pretty much go in the same direction, but when we get to the more intense stuff is when you really start going off in different ways. The first thing I do is I always ask myself, do I have any fraction formulas in here? Like tan is a fraction. Secant is a fraction, right? So I'm going to rewrite it with those fractions in mind. I'm going to leave this alone, and I'm going to replace tan with what? Sine over what? Cosine, right? Because that's the formula. I'm going to leave this alone, and I'm going to replace secant with what? What's the formula for secant? Come on, y'all. First letter. Yes, it's 1 over cosine. You can also look at your formula sheet because I think it's on there. Let's see. I think it's at the top. Formula for secant. See, there it is. Now, here's why I did that. This is where, listen to me carefully. I don't want to say red is wrong, so I'll do like light pink. Light pink is where it's not that it's wrong, it's where it's not helpful. If you're writing your paper, your work like this, hold on. If you're writing it like this, can you tell me what's not helpful here that I clearly fixed up here? Do you notice? Neater is part of it. Do you notice here on mine, cosine is over 1, and I clearly wrote it so that it's in line with the numerator. I clearly wrote it so that the denominator of 1 is in line with the denominator here. Do you see that? There's a reason that's helpful. Because if I look over here, look at this. This looks like cosine times cosine, doesn't it? Because I didn't justify. You know on Word documents when you left justify, that's when it shifts everything left, or right justify or center. I need you to fraction justify. If it's not in the bottom of a fraction, it needs to be level with the top of the fraction. Because what's going to happen is you're going to clearly be able to see, ooh, that cancels. Ooh, that cancels. You see that? Because they're the same factor. Whereas here, this would look like cosine squared, and that's actually wrong. You see the difference? So be careful with how you're writing it. If your writing is a little bit, I don't want to say sloppy, but if you're not writing it to where it's lined up with what it would be in a fraction, it makes it harder to know what to cancel. Because now I can clearly see those are the same exact value, right? So they cancel. What's left? What's left right here? Sine x. And then bring down the minus. These canceled. What's left? A 1 minus 1. That's it.
Why would the 1 still remain if I thought like if there's no denominator on the bottom of the fraction, then it's like
Because it's still minus something. Yeah. It's just like when you divide something by itself, there's still a 1 there. Right? So look how much cleaner this original problem is when it looks like that. And they're the exact same thing. All right, so that's multiply and simplify. Now let's look at this. Factor and simplify. Okay, so let's recall all right, look at this. It's sine squared, cosine squared, plus cosine to the 4th. I'm going to replace sine with y, cosine with x, just so that I can get rid of the trig words and I can just worry about what am I actually dealing with. So watch. This is y squared, x squared, plus x to the 4th. Do you agree? You see what I did there? What do they have in common? There's two terms, two like parts here. You got this term and this term. What do they have in common? What variable do they have in common? Oh, come on, y'all. What variable do they both have? X. This is the GCF. Remember this? This is your GCF. Now, do they have x to the 1st power or anything higher? Can I pull 4 out of a 2? There you go. It's always the smallest exponent. Think of it this way. If I take my family to a theme park, we can only get on the ride that my smallest kid can ride, right? So it's the smallest exponent. Now we do need to write what's left over. So you would divide that out, factor it out. If I factored an x squared out of this mess, what would I be left with? Y squared. And then now if I factored an x squared out of this, I'd be left with what? Or right here? Okay. Y'all recall that? Same thing over here. What do they have in common? I would suggest highlighting your plus and minus signs so you can actually see where the terms break apart. What do they both have? They both have cosine. What's the smallest exponent of cosines? Squared. Now we're going to write what's left. If I factor a cosine squared to the front, what would be left here? Sine squared. Don't forget to write x. And then what would be left here? This was cosine to the 4th. I pulled cosine squared out, so what would I be left with? Cosine squared. And if you ever doubt yourself, multiply it right back in your head and check up here and see if that's what you get.
So we just come up with sine squared and cosine squared.
Mm-hmm. Well, go to your formula sheet. Do you see anything on there that I can substitute? That did not sound good.
I don't know if you're asking or telling us to, but I don't see anything. I see cosine squared minus sine squared. That's it. But I'm not the brightest light bulb in the box, so.
Say that one more time.
I'm not the brightest light bulb in the box.
Oh, you're good. What did I tell y'all to memorize?
Oh, so the answer is 1.
Sine squared plus cosine squared is equal to what, y'all? 1. So anytime you see sine squared plus cosine squared, now it does have to be by itself. There can't be extra stuff with it. This is coupled into inside parentheses. So this hot mess right here, this is actually 1. So this is cosine squared x times 1, which is what, y'all? Cosine squared x. Anything times 1. Your normal rules apply. Anything times 1 is itself. Anything divided by itself is 1. You just have to know when you can substitute. Now, you see how this was messy, but I pulled a trig identity, and I said that's actually just 1. So now this is cleaned up. Okay? That is the snapshot of Chapter 7. It's all about, do you recognize when something can be replaced by a formula to make it cleaner? That's the hardest part of Chapter 7. It's all about puzzle approach. So it's very similar to when you're putting a puzzle together. You have this technique of, I don't know about y'all, but I always try to do the edges first, find the 4 corners, and then I work my way in, right? And then I also try to work on like certain really bold parts of the puzzle because they stick out more. This is a puzzle approach. It drives people nuts because there's no one way that works every time. And it's really going to push you out of your comfort zone, okay? Now, I have good news and bad news. The bad news is it is the toughest chapter because of the whole puzzle concept. The good news is when we get closer to the test, the only proof questions on the test will always come from ones we've done in class or homework. I'm not going to throw a new one at you that you've not seen before, okay? Does that make sense? So, and now we will have a lot that we've got like under our belt, but everything I'm going to put on the test is something we've done in the notes or in the homework. So you've seen it at some point, okay? So keep that in mind. I would go in and see what you can go ahead and start on my math lab. I do have a note to myself, number 2, 4, and 7. I don't remember what that note means, so I'm going to look at it.
I felt like we need to scare Garrett with this, so I took a picture and sent it.
Oh, Lord. Oh, my word. No.